Hey students, so you've already hopefully seen the shortest path problem. This is its twin, longest path problems. This is when you want to go through a directed network or a weighted network, sorry. Each edge has a certain value assigned to it, and you want to ask yourself, what's the longest way to get from one point to some other point? What will maximize these numbers on your way through? So you might be in an orienteering competition where the longer you go, the more points you're going to get, for example. But there's lots of ways. You could be like if you're doing advertising of some kind and you want to hit as many houses or people as you can on each street. Like you want to maximize the number of people you come in contact with from here to here. Then you need to do a longest path analysis. Like shortest path, we've got an algorithm. It's not the same as the shortest path algorithm, but you just box the biggest number. That won't work. It's a slightly different algorithm. We're going to label the starting node 0. Then we're going to find an unlabeled node that is only accessible from the nodes that are labeled. We're going to label it with the maximum length possible. And then we're going to repeat steps 2 and 3 until we reach the finishing node. Once we reach the finishing node, we're going to backtrack through to find the longest path. So I have to take this away. They're a bit hard to read on the screen, but these steps are on page 142 of your textbook or on the OneNote page on longest path problems. So step 1, label the starting node 0. We're starting up here. Oh, that's no good. We're starting up here, so we're going to label it 0. What's the next step? Oh, I should point out, sorry. There's no backtracking in these questions. In longest path problems, there's no backtracking. Why? Because if there was backtracking, it wouldn't be a very good question. What's the longest path? Because you could just do this. Go back and forth between two nodes, racking up points, or you could just go in circles. You could just go like this in figure eights. And you could go on infinitely and get your score as big as you like. So we're only interested in situations where there's no backtracking. Alright. So I'll start again. Label the starting node 0, and then find an unlabeled node that is only accessible from nodes that are labeled. So this one is only accessible from this one, which is labeled. And then we're going to label it with the maximum length. So it's the only one we've got at the moment. The other one that is only accessible from nodes that are labeled is this one. We'll label that with 7. And then step 3 is just repeat step 2. Look at nodes that are only accessible via labeled nodes and label them. This one up here, for example. The only way I can get to it is by this node, which is labeled. So I can label it. There's only one way I can get to that. So that's the way it's going to be. 4 plus 2 is 6. This one here, I can get to from this node, and that's my only options, but they're both labeled, so I can go ahead and label this one. 4 plus 4 is 8, 7 plus 2 is 9, the biggest of those is 9. This one here, only accessible from that one, 7 plus 5 is 12. This one here I can get to from here and from here. They're both labeled. This one's 9 plus 8, which is 17. This one's 12 plus 1, which is 13. 9 plus 8 is the biggest, 17. Let's look at this node here, the finishing node. How can I get to it? I can get to it from here, which is from a labeled one. I can get to it from here as well, and because this one isn't labeled, I'm not ready to label this one yet. So this one here I can get to from this 9 and from this 6 vertice up here. All options are labeled, so go ahead and write in the maximum way. 6 plus 4 is 10, 9 plus 3 is 12, 12 is bigger than 10, 12 goes in there. Lastly, I'm up to my finish node. So 12 plus 5 is 17, 17 plus 1 is 18. 17 plus 1 Oh, I've labelled this one wrong, sorry guys. Oh no, let's just do it like that. I want to make it the same as in your textbook. So sorry, this is meant to be a 6. That means 17 plus 6 is 23. So this example is in your textbook if you want to follow it again. So 17 plus 6 is 23. So now what I have to do is backtrack through all these decisions I've made and find what the longest one was. Same in Dijkstra's. We just go, did I get here along this node? No, because 23 take 5 is 18, not 12. But 23 take 6 is 17. So I know I travelled that node. 17 take 1 is 16, not 12. But 17 take 8 is 19. 9 take 2 is 7. And 7 take 7 is 0. That's it. Now I have my longest path. And it'll work for any network you want to do. Good luck, guys.